Hey there, class. Mr. Prosky here. Hope you're having a good day so far. We're continuing with 6.3 today, which is about similarity and polygons. So the name of the lesson is use similar polygons. Our essential question is, what is the process for solving dimensions of polygons using their perimeters? What we need to review what a polygon is, just for a review here. So, for example, let me draw some shapes here. I'll draw this. The lines may not be totally straight, but just kind of imagine that they are, okay? Say we have that. Say we have this. Let's see if we have that, and we have that. So if we number these, 1, 2, 3, 4, and 5, why don't you pause the video and see if you can identify which of these are polygons and which of these are not. Okay, number 1 is not a polygon. Why is that? Well, it has sections. There's 2 sections here, so that makes it not a polygon. So that one is not going to work. How about number 2? Got kind of an ice cream cone looking shape. That is also not a polygon because it has curves. Okay. Number 3 is basically a square. That one is a polygon. That one works. Number 4 is a triangle, which is also a polygon. And number 5 is not a polygon because it is not connected. So the big things, it's basically a 2-dimensional shape. It needs to have no sections, no curves, and be connected. And that's what makes a polygon. We also have a warm-up here. It says 2 cities are 125 miles away in real life and 8 inches away on the map. What is the scale of the map? Why don't you guys pause the video and see if you can do this review from the last section. Okay, sounds good. So if you remember, we do the type of equation ratio we set up is model over actual. Okay, model over actual. So what's the model distance in this problem? Well, it's going to be 8 inches. And what's the actual distance? 125 miles. Okay, so now we want to reduce this here. We basically divide by the smaller number. Which number is smaller, 8 or 125? We're going to divide by 8 on top and bottom. So we get 8 divided by 8 is going to be 1 inch is going to be the same as about 15.6 miles. And that's our scale. All right, sounds good. Let's talk about some definitions now. Similar polygons are 2 polygons. Okay, actually one more thing, we're talking on the side over here, okay? So we have 2 different things. We have congruence. Let's talk about this. Congruence, which was this symbol, okay? What is the definition of congruence? There were 4 words I associated with congruence that I may have said with you. Well, the first thing is they're the same shape. And the second thing is they are the same what? Same size. Okay? Similarity is kind of like congruence. It's just going to be this symbol, though. And similarity is not, it's one of these two. Is it same shape or same size? It is only same shape. Okay? Same shape, but it could be different sizes. All right? That's the difference between congruence and similarity. All right? So congruence is exactly the same, and similarity is basically they're similar. They have different sizes, but the same shape. Okay? All right, so similar polygons. 2 polygons are similar polygons if corresponding angles are congruent and corresponding side lengths are proportional, or what? Proportional. Okay. All right, the scale factor of 2 similar polygons is the ratio of the lengths of 2 corresponding sides. 2 corresponding what? Sides. Okay, so let's talk about similarity statements here, okay? So we have this diagram over here, and we also have this similarity statement right here. So we are going to, we basically can assume that these are similar figures. And we're going to try to be able to identify the different parts that are going to match up or correspond. Okay? So for example, we'll use a similarity statement, or you could use the diagram either way. We match like the letter with the letter where the position it's in the thing here. Okay? So angle A match with what angle in the other one here? It's going to be angle D. So I want you to write, so angle A is congruent to angle D. Why don't you see if you can figure out the rest of the congruent angles? Go ahead and pause the video. Okay, the next ones would be angle B. Oops. Angle B is congruent to angle E. And the last one is angle C is congruent to angle F. Okay. All right, the next thing is a little bit, so we haven't really done too much. We know how to list congruent angles, but now we're not saying that the side lengths are congruent or equal. We're trying to check that the ratios are equal. They're proportional. Proportional means that the ratios are all equal, okay? So let's use a different color here. So we're going to match the side lengths, and we're going to compare, we're going to reduce the ratio and see if they're all equal. So for example, we have AB, let's start with AB is one side length. Which side matches with AB over here? Well, it's going to be DE. So we have AB over DE, okay? So AB over DE, what are the sides that match with AB and DE? Well, AB is 10, so we do 10 over, what's DE? DE is 15. Now we want to reduce this. You always want to reduce your ratios, otherwise it looks like that they might be different when they're actually not. So what number goes into 10 and 15 nicely? 5. 5 goes into 10 2 times, and 5 goes into 15 3 times, okay? So this is going to be the ratio of those side lengths. And if this is indeed proportional, then the other matching side should also have a 2/3 ratio, okay? Why don't you go ahead and pause the video and see if you can come up with the other ratios here and see if they're going to be equal or not. Go ahead. All right, the next one we had was AC over, you may have done a different one here, but AC over DF. So AC was 12 over DF, which is 18. And if we reduce that, 6 goes into both those numbers. 6 goes into 12 twice. 6 goes into 18 3 times. This one also matches. All right. Last thing we have is BC over EF. All right. And the side lengths are going to be 8 over 12. All right. What number goes into 8 and 12 nicely? Well, it's going to be 4. 4 goes into 8 twice. 4 goes into 12 3 times. Is that all the sides? It is. And are all the ratios congruent or equal? They are. So this is good. This means that so far they are similar. The angles are congruent and the side lengths are all proportional. All the ratios are the same. So far these are similar figures, all right? And the last thing we need to do, which is going to probably be on a quiz, is that we need to write the corresponding side lengths in a statement of proportionality. Basically, we're just going to take all the different the ratios from here, and we're going to set them equal to each other. That's all it's asking you to do, okay? So AB over DE is equal to, what's the next one? Well, we have AC over DF, and we have BC over EF. And that is the statement of proportionality between the sides. Okay, I'm going to leave it zoomed out here. Why don't you try checkpoint 1? It's very similar. There's no drawing. If you'd like to draw the two triangles to help you visualize it more, that's fine. Otherwise, you can use the similarity statement right here to help you with it. Okay, go ahead and give it a try. All right, let's do this one. So we have to list all the congruent angles. So angle P is congruent to what angle? Angle X. Angle Q is congruent to what angle? Angle Y. And angle R is congruent to what angle? Angle Z. Okay, so those are the angles. And then we need to list the side lengths that match up. So PQ matches with XY. Okay, and if you keep going, you would have QR over YZ. And we would have RP over ZX. Okay, and this is going to be the congruent angles, and then this is a statement of proportionality right here. All right, sounds good. Okay, so in the last example, we were able to show that we could assume that the two shapes were similar because they gave it to us that way. This time we're going to actually prove that they're similar, okay, which is actually a little bit different. It's the same kind of process, but we actually have to show that everything matches up nicely, okay? So step 1. We have this shape ABCD and JKLM, and we're trying to show that they are similar. So first thing we need to do is show that all the corresponding angles are congruent. So if we kind of look closely here, angle A is a right angle and angle J is a right angle, so we can see that angle A is congruent to angle J. And if we go around the shape here, we have angle B is a 1 arc and angle K is 1 arc. Remember, if they have the matching number of arcs, they're going to be congruent. So angle B is congruent to angle K. And you can see if you go around there that L has 2 arcs, so does C. So it would be angle C is congruent to angle L. And the last one we have is angle D is congruent to angle M. So far so good. All the angles are congruent, and we can say that part of the similarity is good. The next thing we need to do is we need to show that the corresponding side lengths are proportional. Are what? Proportional, which means that all the side lengths match up and have the same ratio. Okay. So one thing we need to know here, we have 2 different size shapes here. We have a small one, right? This is the small shape, and this is the big shape. Okay. I would encourage you. You could go big to small or small to big, but be consistent, right? Because if we go back to this problem over here, if we did like we flip this around, we did like DF over AC, we would have 3 over 2, and that's not the same ratio. But that's because we flipped which order we were going from. We went from small to big every time, so we have to go from small to big every time, otherwise it's going to mess up our ratios, okay? So down here, let's do small over big, okay? Let's do small over big. I think that makes it easy. So small to big is how we're going to compare these here, all right? So let's go ahead and do this. So we have, let's start with AB, right? We're talking about this right here. So we have AB over what side matches with AB? Well, it's JK. And side length AB is 8. Side length JK is 14. And if we reduce that, we divide by 2, we get 4/7. Okay? So if these are proportional, then all these different side lengths should also be 4/7. If there's even one that doesn't work, they're not going to work here, okay? So next we have BC, which matches with KL, which equals 8 over 14 again, which is also still going to be 4/7. Why don't you pause the video and see if you can come up with the other sides, and go ahead really quick. All right, next one we have is CD over LM, which is going to be 8 over 14 again. A lot of 8 over 14s here, which is also 4/7. And the last one we have is DA over MJ, and that's going to be 12 over 21. And what number goes into 12 and 21? I think it's 3. 3 goes into 12 4 times. 3 goes into 21 7 times. Oh, look, these are all the same ratio, so that means that this works and this works. So these are similar figures now. And now what we can do is we can write a similarity statement and identify the scale factor, which we'll talk about in a second here, okay? So the similarity statement, all we have to do is start anywhere and go around the diagram and go both directions, or go the same direction for both. So we can do A, B, C, D is similar, this shape, and then it would also be J, K, L, M. So that's a similarity statement. The scale factor is just going to be the ratio that we got when we compared the different things here, okay? Oh, one thing I forgot to mention is that if they want you to compare it from this to this, you have to go that direction. So we could do small to big or big to small, but we want to kind of be consistent here, okay? So, 4 to 7 scale factor is just going to be 4/7 in this case. That's the ratio. And there we go. All right, moving on. Let's talk about similar polygons now. So, now that we know how to find the scale factor and we know how to do similarity stuff, let's go ahead and do this. So, we know that these two shapes are similar because we have a similarity statement. And we're trying to find the value of x, okay? So what we need to do first, what's right here? We need to find one pair of matching sides. Matching sides with numbers for the scale factor, okay? We need numbers for both things to find the scale factor here, okay? So why don't we look at these sides here. So, for example, we know CB matches with SR, and we have 12 and 24. Are those both numbers? Yep, that would work. We could also do BD and RT, which is 5 and 10, but we can't do 13 and X because those are not numbers. We have to do that. So let's see what we do in a second here, okay? So let's do small to big again. We'll do small over big. Kind of keep it consistent. Okay, so for this. So let's do the 12 over 24, right? 12 over 24 is the comparison of those two sides. And if we reduce that, what's that going to reduce to? Well, that's going to be 1/2. Okay, and this is our scale factor. All right? That's our scale factor. Then what we're going to do is we're going to set up a proportion. Okay? We'll set up a proportion to solve for the missing side. We're trying to look for this 13 and this x here. Okay? So we have 1 over 2 equals, and now what we're going to pick, are we going to put 13 on top or x on top? Well, we're going small to big, and 13 is with the small side, so we have 13 over x. Okay? And then we need to solve this. How do we solve proportions? Well, we cross multiply, so we get x equals 2 times 13 is 26. Now, you may be able to look at this and just say, oh, 5 times 2 is 10, 12 times 2 is 24, so 13 times 2 is going to be 26. And it may work out that nicely for some of these, but like if you have a scale factor of 4/7, it's going to be hard to kind of figure out what number is going to work nicely, okay? So I would encourage you to do the proportion like this, but yeah, whatever works best for you. Okay, checkpoint 2 is very similar. Why don't you guys go ahead and try checkpoint 2? Give it a try. Okay, so checkpoint 2. What is the scale factor of LMNP to FGHJ? Okay, let's pick two sides here. Where's some two matching sides? Let's do small to big. Oh, wait, LMNP. Yeah, we have to go. So we're going small to big, okay? Small to big is how we're comparing this. Let's do 16 over 20, okay? 16 over 20 is LP and FJ. All right, so if we reduce that, 4 goes into 16 4 times, 4 goes into 20 5 times. So our scale factor is going to be 4/5. Now we got to set up a proportion here, right? So we have 4/5 as our scale factor, and we're looking for x. Well, x matches with what side over here? It's going to be 40, so we're going to do x over 40. Cross multiply, we get 5x equals 160. Divide by 5. Get x equals 32. Awesome. All right, sounds good. Let's keep moving here. Okay, something to note about similar polygons, okay? All the side lengths are going to be proportional, and so is the ratio of their perimeters, okay? So you can either, so if we put in these blanks here, KL over PQ, the side lengths, all the ratios will be the same, but also the perimeters will also be proportional, which means like basically if you figure out the scale factor, you can use that scale factor to like solve for the perimeter in kind of a cool way, which we'll see in a second here. We have MN over RS, and we have NK over SP. So this is kind of a challenging problem here, but just stay with me and we'll be good, okay? All right, example 4, find perimeters of similar figures. A larger cement court is being poured for a basketball hoop in place of a smaller one. The new court will be 20 feet wide and 25 feet long. The old court was similar in shape, but only 16 feet wide. Find the step A says find the scale factor of the new court to the old court. So we're going to do new over old. Okay, that's the ratio we're going to use. Okay. Well, what do we know about the new court and the old court? Well, we both know that the old court was 16 feet wide, and the new court is going to be 20 feet wide. So that's all we know. So we can figure out by comparing those two sides there, right? We can do 20 over 16, and then we reduce that. What number goes into 20 and 16 nicely? Well, it's 4. 4 goes into 20 5 times. 4 goes into 16 4 times. So this is our scale factor, okay? This is going to be the comparison between the lengths of the sides. It's also going to be the ratio between the perimeters of the two new shapes, okay? So that's scale factor for sides, and so let's write that up here. Let's write sides and perimeter use scale factor, okay? Sides and perimeter both use the same scale factor. All right, let's talk about this here now. So find the perimeters of the new court and the old court. Let's make some drawings here, okay? So let's do the new court over here. I'm not going to draw it perfect, but we'll see how we do. So the new court, okay, looks like the length is 25 feet. These are both 25. And the width is 20. And we know the perimeter, I'll put the perimeter in here, the perimeter was 90 for the new court, okay? All we know for the smaller court, we had the old court, okay, was the perimeter we don't know. And we know that the width was 16, okay? All right, well, let's do this here. So So we actually don't need to know the rest of it. We don't need to know these sides here. Because now all we have is we have a scale factor, so we can actually just compare the perimeter to the old perimeter, okay? And you'll see what we do here in a second. So let's set up our proportion, right? So 5 over 4, which is new to old, okay, equals, what's the perimeter of the new court? Well, it's 90. Does that go on top or bottom? Well, we're doing new over old, so 90 goes on top. And on the bottom, we're just going to put an x. We don't know what that is, but that's okay. Then we just do our normal solving. We cross multiply. We get 5x equals 4 times 90 is 360. Divide by 5. And we get x equals, oops, not over there. We get x equals 72 feet. And that's the perimeter of the old, court. Okay? Oh, and I found the perimeter, sorry, I didn't mention that though. I found the perimeter of the new court by just adding up all the different sides here to get that. Okay? All right, sounds good. That's a little confusing. Why don't you guys, okay, let's talk about this here. Corresponding lengths and similar polygons. Yeah, it's kind of tricky. Okay, let's go ahead and we're going to write some perimeter problem. Let's write some notes over here. So perimeter problems. Oops. Okay, let's write the steps for perimeter problems. So first step. Find the scale factor. Okay, always find the scale factor first. Step 2. Find one perimeter. And you're going to add up the sides. Okay, you'll have enough sides to add up one of them. Step 3. Set up proportion with scale factor and perimeter. And then you're going to solve. Okay? All right, let's go ahead and do this here. So we have corresponding lengths and similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor, to the what? Scale factor of similar polygons. Okay, we have checkpoints 4 and 5. Why don't you guys pause the video and see how you do with these? Okay, so we're going to kind of use our perimeter problem here, all right? So we're looking for the perimeter of this one, and we only have one side length here, okay? So the first thing we need to do is we need to figure out the scale factor. So step 1, so the scale factor, let's see here. Let's do small to big again, okay? So what side matches, the only length we have here is 40. What side matches with 40 in the other polygon? 72. So if we do 40 over 72, what's 40 divided by 72? If we reduce that, I think it's 8. 8 goes into 40 5 times. 8 goes into 72 9 times. And that equals our scale factor. Step 2 is to add the perimeter of the one we know, which is all these over here, right? So if we add those all up, we have the perimeter of the big equals 72 plus 63 plus 81, which equals 216. Okay. All right. And then step 3 is we need to set up a proportion here. So let's do that. So we can do our scale factor. So we can do 5 over 9 equals, we're looking for the perimeter of the small one, which is going to be x over 216. And we go ahead and we cross multiply. So we get 9x equals 5 times 216 is 1080. Divide by 9. And we get x equals 120. So the perimeter of the smaller one, without knowing the other side, is going to be 120. Okay? All right, last example. Let's talk about this one. This might be a little bit weird, but we'll see how we do here, okay? All right, so first things first, we need a scale factor here, okay? So these are all congruent here, and these are congruent. So the matchup we can do is, we'll do small to big. We're going to do 16 over 24. We reduce that, 8 goes into 16 twice. 8 goes into 24 3 times. So that equals the scale factor. All right. We're looking for the length. So we can do 2 over 3 equals, we know this is 39, and we're looking for this. Let's call that x. We can do x over 39. And we can cross multiply. We get 3x equals 2 times 39 is 78. Divide by 3. we get the x is going to equal 26. That last one's a little tricky, and don't be too panicked about some of the perimeter problems. Those are pretty challenging. But thank you for watching. Have a great day, and we will talk soon.